With this lesson, we're going to look a little bit further at the graphs of the sine function and the cosine. Particularly, I'll look at the graph of the sine function and some transformations we can do to it, but the ideas apply exactly the same to the graph of the cosine function. So you should watch this video after you've completed question number 6 on page 523 in your workbook. If you haven't finished that question, then you should stop the video, go back, do the question, and then come back to the video. All right, so this is tied into lesson 5.6, and we're looking at the graphs of the trig functions again. So, if we have a function y equals f of x, if we compare to that function y equals 2 times f of x, then we see that that is going to be a vertical stretch by a factor of 2. For y equals f of 2x, you'll recall that this is a horizontal stretch by a factor of a half. For y equal f of x minus 2, with the minus 2 in the parentheses with the x, that'll give us a horizontal translation of 2 units to the right. And finally, if we have y equals f of x plus 2, where the plus 2 is outside of the function, then that's going to be a vertical translation of 2 units up. So we're going to look at these same ideas as they apply to a sine graph. So here again we see the graph of y equals sine x. That's the graph that's already drawn. Now, if we want to graph y equal 2 sine of x, then this will be a vertical stretch by a factor of 2. And so this point that was on the x-axis needs to stay there, because 0 times 2, we're multiplying y values, remember. 0 times 2 is still 0, but this point, where we had a y value of 1, is going to be multiplied by 2, and that'll give us a y value of 2. And so that point will be stretched up to here. Similarly, this point is unmoved, but this minimum is stretched and goes down to negative 2. And that point stays on the midline. And so the shape of our graph will be similar, just stretched out, and again, hopefully your curve looks better than mine, but this gives us the idea of what that multiplying by 2 does to the graph of vertical stretch by a factor of 2. Okay, let's move down to the next graph. Now where we have the 2 multiplied to the x, so this is the sine of 2x, we'll have a horizontal stretch by a factor of 1/2. So all the x values will become half as large. So this where x was 0 is going to stay there, but if I look at this point, where x was pi, now it's going to be stretched by a factor of a half, and that point will end up here at pi by 2. Similarly, this point that was at 2 pi is going to be half as far away, and it'll end up at pi. The maximum point that was at pi by 2, now half as far along the x-axis, so it'll be at pi by 4. And similar for the minimum point, it'll be at this point here. And so the shape of our graph will just be horizontally stretched by a factor of a half like that. So that gives us one cycle. We could continue the pattern going, and maybe I will do that just because I haven't emphasized the fact that this function does continue going, and in fact it continues off the graph even to there. So we could continue sketching the sine wave looking like that. Same idea in the negative direction. So there we go, if we have something multiplied to the x. So what this is doing is it's changing the period of the graph. So now we have a period, the graph starts here, goes through a complete cycle, the period is only pi now. So we have a period of pi. And in general, we'll say that the period will be 2 pi divided by whatever that value is that's multiplied to the x. So if we think of having the sine of b times x, and if this is our function, then this is our period, 2 pi divided by b. Let's take a minute to look back at our previous graph. Here what happened is when we had this 2 multiplied to the sine of x, it changed our amplitude. So the amplitude of y equals sine x was 1, now this amplitude is 2. So if we have y equals some value times the sine of x, then our amplitude is going to be this a value. Let's go down to the third graph. So with this equation where we have an x minus pi by 2, now notice I didn't use a 2 this time because a 2 is just hard to graph given this scale. So I decided to choose a value that was going to be easier to draw on this grid. So I'm going with a pi by 2. This is going to result in a horizontal translation to the right of pi by 2 units. So this point is going to move to the right half a pi. This point will move to the right half a pi as well. So we'll have this point here. The next 0 will be here. And then the next 0 is off the grid. This maximum point moves pi units to the right. And so there's where my maximum will be. And my minimum similarly will move pi units to the right. So that gives me part of the graph. As I just look at the pattern here, I see that there are 3 grid lines in between each point on the center line and each maximum or each minimum. And so if I go back 3 grid lines, I'll have another minimum over here. So I can plot this point, just have a more complete curve that's going to show up. So we have our curve looking like this. And again, kind of spidery the way I drew it, the way this app works for me, but you can do a better drawing. So we call this a phase shift. So a horizontal translation, when it comes to periodic functions, we refer to as a phase shift. And in this case, it'll be pi over 2 to the right. Let's move on to our final graph. Not a difficult one. This plus 1 that we have after the sine function, essentially what it does is it takes this midline, that center line, and it moves it up by 1 unit. And then from that line, the graph will start on the midline, go to a maximum, back to the midline, down to a minimum, and then back to the midline. So we can plot the points on the midline, the maximum on the midline or center line, minimum, and then back on the midline. And then we can sketch a smooth curve here. And again, hopefully yours looks better than mine, but that gives you the rough idea. So sometimes this is referred to as a vertical displacement. So might be called a vertical translation or vertical displacement. Either term you should be familiar with. Yes, that word does say displacement. Use your imagination. Come on. Okay. So all this information is summarized in your workbook as well. On page 520. Now here they've written it in terms of cosine, but it's the same for sine and cosine. So here's the summary. If we have an x minus c, and we're taking the cosine of that, we'd say it's translated horizontally by c units. If we have some number in front of the trig function, then that's going to be vertically stretched, and that stretch factor is a, and if this a was negative, and that's not something we looked at, but again we'd have a reflection. So the graph of y equals sine x that typically looks like this. If we had a negative sign in front, we'd get the reflection and it would just look opposite where this is the x-axis. Okay. Thirdly, if we have some number multiplied to the x, then we say it's horizontally stretched by a factor of 1 over the absolute value of b. And again, if this was negative, then we'd have a reflection in the y-axis. We didn't look at that, but it's similar to what we've done with the transformation unit. And finally, if we have some number added on the end, then it's going to be translated d units vertically. Okay, so that summary is in your book, and you have an assignment that has been listed on Edmodo and given to you as well, so you could work on those questions. All right.